Hello everyone, I am Peter John Iyamaya, and for today's video, I'm going to demonstrate three following topics. First is the general solution of any linear Diophantine equation of the form of ax plus by equals c. Second is to perform the four arithmetic equations involving functions. And lastly, third is to find the inverse of one-to-one function. You can actually see this after this video. I'm gonna show you guys a quick tutorial about to find the LDE of the form of ax plus bx equals c. So when we have 258x plus 147x equals 369 here, this is our LDE. So first thing to get it is to follow the Euclidean algorithm. So here it is how it took like to get the GCD, or the greatest common divisor or factor. So before we proceed to the solution, so here 258 divide 147 equals 1 with the remainder of 101. So we use 147 as our dividend, and it divides to 111 equals to 1 with the remainder of 36. So 101 divide 36 equals 3 with the remainder of 3, and 36 divide 3 equals 12, which is there's 0 remainder. So we can actually transform it into here, which is our Euclidean algorithm. 111 equals 258 minus 1 times 147, and here is 36. 147 minus 1 times 101, and here 3 was 111 minus 3 times 36, and last is 0 equals 36 minus 12 times 3. So to get the x and y, we have the solution here. 3 minus 111 by 3, 36, which is we get from the equation 2 here, and 3 equals 111 minus 3, 147 minus 1 equals 4, and 1 equals plus 3, 147. So 3, 4 here. So now I get the time 258 minus 147, which is we get from the first equation, and minus 3 times 147. So equals, we get that 258 have 4 and plus 147 has negative 7. So here. So let's proceed to the general solution of our LDE. So here, this is how it will happen. For sum of gain of positive integers. So here CM divide D, and our Y plus Cn and divide d. So our A is equals to 258, our B is 147, our D is 3, which is our GCD, or greatest common divisor or factor, and our M is 4, which is our X, and N is our Y, which is -7, and our C is 369, which is our L, coming from our LDE. So to get this, we have this 0 cm over D, or 369 times 4 over divide 3 equals 369 times 4 and divide 3 equals 492. So our Y is Cn divided D equals 369 times -7 over 3 equals -861. So here we should follow this, equals 492 plus 147k over 3, and our Y is -861 plus 258k over 3, so which is, we get from X equals 492, which is 147k divide 3, which is, we get 49k, and our Y equals -861 minus, which is, we get this 258k divide 3 is 86k. We should find the solution of positive integers. So here 492, which is, here's the positive integer, 490 plus 49k is greater than 0. So 49k over 49 crossed out, and greater than -492 over 49. So we get k greater than -10.04, while the Y is -861 minus 86k greater than 0. So 86k over 86 crossed out, greater than 861 minus, I think, over -86. So we get k is less than -10.01. So let's proceed to negative integers, which is 492 plus 49k, which is less than 0 already here. 49k over 49 cancel out this, which is less than less than or greater than 492, -492 over 49. We get k is less than equals 10.04, while the Y is Y in negative positive integer is -861 minus 86k over 86, which is crossed out, which is here less than 0 or less than equals 861 over 86. So we get, let's proceed to, we're going to talk about how to find the inverse of a function. So consider that the function of f of x equals 7 over x minus 5. So step 1 is write the equation in the form of y equals f of x. So step 1 is y equals 7 over x over minus 5. So step 2 is interchange x and y. So like this, x equals 7 over x minus 5. Step 3 is to solve for y. Just like this, x equals 7 over x minus 5. So x, y minus 5 equals 7, and no just x, and x y over minus 5 x equals 7. So let's change the sign like this, plus 5x plus 5x. So we cancel out this, equals 0. So here is the result, xy equals 7 plus 5x over x. So put into here, so 7 plus 5x, or f minus 1 equals 5x plus 7 over x here. So here, so let's verify if f of x equals 5x plus 7 over x and g over x equals 7 over x minus 5 are inverses. So it's like this, 5gx equals f over 7 over x minus 5 equals 5 7 over x minus 5, which is the g of x, plus 7 over 7 over x minus 5. So equals, here is 35. So it's 5 times 7 equals to 35 over x minus 5 plus 7 x minus 5 and x minus 5 over 7 for x minus 5. So the result here is 35 plus 7 equals x minus 5 equals x. So it's like over 5. How we do this is 35 plus 7 equals minus 5 times x minus 5, which is 7. So here same denominator and crossed out and and equals 35 plus 7 minus 35 over 7. So cross out, it equals x. So proceed to g of x equals, g is 3 no, it's 5 x plus 7 over x 7 5 times plus 7 over x minus 5. So here, how we're gonna do that is 7 over 5 times plus 5x plus 7 minus 5x over x, which have the same denominator, and 7 over 7, which is x, So how we gonna do this? How we gonna find 7 over 7 equals 6? So how we gonna do this is 7 over 1 times x 7. So crossed out and crossed out. So how we do this is x over 1, which is equivalent to x also. So we have the correct answer. So I would say that the fx f 5x plus 7 over x and g of x 7 over x of minus 5 are inverses. Problem, guys, is what we're gonna do is I'm gonna show you guys to do all 4 operations as well as identify the domain of functions. So the most important thing is we need to understand operations. That's what I ask you guys. So we need to annotations gets difficult, but if you guys have tried this, you realize it's not that difficult. Just combining functions. You're just doing simple 4 basic operations: subtract, multiply, divide, and not to say that always easy, but I'm just equation that I must do is not that difficult. However, there's times where this starts to get complicated though, pretty quickly, especially when we get over here. So here, add fx to add plus g of x, which is square root minus 3x plus 2. I recommend you guys are replacing x minus 2 and plus x. I like to put in parentheses. To me, in my brain, that just triggers that's I replace x minus 2 in for fx, right? Because all you're doing is fx plus g of x, f of x plus g of x. Now you could just combine like terms. I can combine anything with x squared. Then I have x equals negative 3x is negative 2x, and negative 2 plus 2 is just 0. So I'm gonna leave it out. Then I'm going to deal with domain. My domain, this energy restrictions that I talk restrictions about here. So denominator or in radical, there's nothing for me to believe that there's no restriction, of course. Negative infinity to infinity or all real numbers. Okay, guys, same thing. Okay, so I prefer this method though, but if you want to write all numbers as long as you understand this works as well, or you know this, then that's okay. Again, it's important to use parentheses because now when you're doing subtraction, everything about the sign is matters, because I have to make sure it's subtraction, not just x squared, but I'm subtracting all of these values. So in reality, this is x, so I have to subtract, so negative x squared. Therefore, I have minus negative 3x, which path is 3x, x minus negative 3x, double negative, so it's 4x. Here, I have negative 2 minus 2, so equals 4. So let's go to our domain. So there's any restrictions? So no. Negative infinity over infinity. Done. The next thing is multiplication. Again, using parentheses is very helpful. So what you can see here is binomial to, but it's perfectly fine. I have no problem with that. I told you that I didn't like using yeah, we use Bax method for radical expressions, but I liked for when you're dealing with polynomials, I prefer to use the Bax method. You don't have to use the method. Whatever you guys are comfortable with is perfectly fine with me. But I like the Bax method because it organizes everything very, very nice. Well, just multiply, define the area of each box. So x cubed minus 3x squared plus 2x minus 2x squared plus 6x and minus 4. Yeah, it's as long as you have your polynomials in descending order, you have like terms in the diagonals, so it's easy to combine like terms to diagonal. So therefore, my answer is x cubed negative 5x squared plus x minus 4. So domain, there's no restriction, so domain is all real numbers. We got something a little bit tricky about as f of g of x. So in this case, I have x minus 2 all over x squared minus 3x plus 2. Now in this case, you guys can see that this is divided into that. No, right? This larger power. You can't have the x cubed that's not divided into that. Therefore, I'm going to divide into, so we can use long division or synthetic division ever. We can factor our denominator. If you guys factor denominator, x squared minus 3x plus 2, what's multiply to give you to add to give you negative 3? So x is 3 equal. So if I write this in factorial form, x for x, there's what you want to notice. First of all, before I simplify this fully, what two numbers makes my denominator equal to 0? So to do that, what you're gonna do, if you guys remember, have a fraction, always set your denominator equal to 0. So this my denominator, set my denominator to 0. Can I apply to 0 property? So that I can send x equals 2, x equals 1, x minus 2 or x minus 1, my denominator is equal to 0. When my denominator is equal to 0, that's not going to be my function. So my term for my domain is all real numbers such that x is not cannot equal to 2 or 1. So I just want to make sure you know this. When we simplify this, my x minus 2 and my x minus 2, since my denominator by multiplication divide out, there's only 1 up there. We can't get over it. So final simplified answer is here. Let's put here is 1 x minus 1. So this is the simplified answer. Always looking for factoring by simplifying it, and so forth. So thank you guys for watching this video about arithmetic of functions. I hope you learned something from it. Hope you learned something, guys, and thank you guys for watching this video.